Good afternoon, ladies and gentlemen, and welcome to the SAIEE Free State Centre webinar on Cast Resin Transformers, the path to a greener future. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on their device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV. The link to the registration is in the chat box. Please subscribe. And a recording of this webinar will be listed under the Free State Centre playlist. A certificate of attendance will be issued a few weeks after this webinar, once we've received the CPD validation from EXA. I'd like to introduce you now to our host this afternoon, Mr. Thabang Matau, who is the chairman of the SAIEE Free State Centre. He received his Masters of Electrical Engineering degree from the Central University of Technology, Free State in 2020. And received the Professional Engineering Technologist status with the Engineering Council of South Africa in 2010. In 2017, he joined Group Technology Standard Implementation, overseeing the management of Eskom's distribution, strategic and critical spares nationally, the investigation of pole mount and power transformers nationally in distribution, material evaluations, and compiler of maintenance and asset management standards. Over to you, Mr. Matau.
Thank you, Chair. Thanks, Mix. Good afternoon, attendees. Let me take the opportunity to greet all the attendees of our live webinar, currently watching from various locations. It is a pleasure to be sharing with you a very interesting topic on right-type transformers. Please take note that under the menu there's a menu called a chat. So under the chat there, you'll see how you can become a member for SAIEE. And there's also a website that you can click there, and also check out the SAIEE Training Academy CPD course offerings. There's a link there that you can click also to check for that. And also you can even subscribe to SAIEE TV channel on YouTube. It's for free. You don't pay any cent for it. There's a link also that can take you through there. And also you can download our latest magazine called What Now? There's a link there that you can read some of very interesting engineering topics. Okay. Next now, I want to introduce our speaker. Let me take also the opportunity to introduce our speaker, Mr. Zander van Rooyen. He's a technical quality manager from Revive Electrical Transformers. Zander van Rooyen started his career in 2021 in food industry, which included electrical construction and mechanical automation, where he gained on-the-job practical experience. He received his Electrical National Diploma N6 in 2001 and completed his electrical trade test in 2012. In 2013, he qualified as an inspector of electrical installations and internal auditor, ISO 9001 in 2021. He currently manages the manufacturing process of oil-filled and cast resin transformers, reviews client requirements, and assists with design parameters, project management, site-related works, investigations, installations, maintenance, and research and development of products at Revive Electrical Transformers. Mr. Zander, over to you. Thank you.
Perfect, Zander. You muted, please. Unmute.
Oh, okay. So welcome to all the attendees. Thank you, Mr. Thabang, for allowing me to present this webinar on Cast Resin Transformer, the path to a greener future. So let's quickly have a quick introduction to cast resin transformers. Cast resin transformers appeared early in the 1980s in Europe. This new style of cast resin transformers was developed with HV windings cast under vacuum in epoxy resin. The new cast resin transformer very quickly became an ideal alternative to standard dry type transformers with exposed windings. In the early 1990s, cast resin transformers were manufactured in large quantities, and they became the preferred alternative for high-risk installations. Cast resin transformer technology has since improved and allows cast resin transformers to be manufactured to the highest quality standards, ensuring reliability and efficiency. Today, cast resin transformers are used all across the world with various applications and installations. Some of the typical installations would be nuclear plants, petroleum plants, harbors, airports, underground mines, renewable energy, and general distribution. Due to the fact that cast resin transformers is a relatively new product in Southern Africa, not a whole lot of information regarding cast resin transformers is freely available locally. This webinar will hopefully inform and educate the general engineering community and assist engineers, project managers, buyers, and contractors when procuring cast resin transformers. Let's have a look at the relevant standards and specification for cast resin transformers. Cast resin transformers are designed, manufactured, and tested and installed to comply to various local and international standards. The most common local standards adopted from the IEC are listed on the screen. The most important one for me that needs to be considered is the SAN 676-11 for dry type transformers. In this standard, all the relevant requirements and parameters for manufacturing, designing, and testing of dry type transformers are mentioned. In this standard, they also refer you to all the other relevant standards typically listed on the screen that cast resin transformers needs to comply to. There are various other standards and regulations that also needs to be kept in mind for the installation and application of cast resin transformers. It is always suggested that you ask your manufacturer, supplier, or installation specialist for advice should you not be familiar with the needed standards or specifications. Something to keep in mind when procuring a cast resin transformer is to always ensure that your supplier of cast resin transformer carries an international or local mark-off certification. This will give you the confidence that the transformer is designed, manufactured, and tested to the needed standards and specifications. Some other specifications to bear in mind when it comes to cast resin transformers are the thermal insulation classes of different cast resin and dry type transformers. These classes are listed in Table 2 in SAN 676-11. You can see you get various different installation system thermal classes from A to R, and then the accommodating average winding temperature rise limits for each thermal class. The most commonly used and commonly found cast resin transformer insulation classes are F, which is rated 155 degrees Celsius, and H class, which is rated 180 degrees Celsius. H class transformers are smaller and have a better heat exchange rate due to the higher temperature allowed for the insulation. These transformers are, however, very costly, and the insulation materials cost is very expensive, and this type of H-class transformer is usually only required for very specialized installations. The most commonly used cast resin transformer in the world is the F-class. This is an excellent compromise between good heat exchange, size, and reasonable cost, making it the preferred practical and cost-effective solution for cast resin transformers. Another specification that needs to be kept in mind when procuring your cast resin transformer is the site installation classes, namely environment, climatic, and fire behavior classes. All cast resin and dry type transformers needs to be designed and manufactured to these classes. Below is a quick guideline of the different classes of cast resin and dry type transformers. The environmental class. The environmental class is defined by the environment the transformer is expected to operate in. For example, class E2 is clean and dry installation, no condensation or pollution. This would be typically an indoor installation where the transformer room or enclosure is kept very clean and tidy, and there is no condensation or moisture present around the transformer. Class E1, occasional condensation or limited pollution. For E1, this is typically an outdoor installation where the transformer is installed outdoors, where medium condensation can occur, and the transformer is exposed to just a little bit of pollution. Class E2 is frequent condensation and high pollution, or a combination of the two. This is usually an outdoor installation where the transformer is exposed to very humid conditions and a lot of industrial pollution is around the environment of the transformer. Let's have a look quickly at the climatic classes. The climatic class is defined at which minimum ambient temperature the transformer can be exposed to. So class C1 is classified that the transformer can operate to temperatures not more than -5 degrees Celsius. The transport and storage is allowed to be a minimum of -25 degrees Celsius. Class C2 means that the transformer can operate, be transported and stored at a minimum of -25 degrees Celsius. The fire behavior class, this is the resistance of the transformer to fire and fire risk. So the class F0 is no specific risk of fire to be considered. So the transformer, there's no exposure of fire or risk of fire to the transformer. Class F1 means there is a risk to the transformer through fire. However, the transformer must be able to suppress that fire, and the toxic gases and smoke should be minimized. As you can see on the pictures, there's a typical example of a transformer being tested to comply to the environmental classes and climatic classes, and another one where you can actually see where the transformer is tested to see if the transformer actually burns. Now that we've had a look at the basic standards and specifications required for cast resin transformers, let's have a look at the basic layout of a cast resin transformers. So cast resin transformers layout and basic components are very similar to that of the oil-filled transformers. You've got a magnetic core, you've got HV windings with the relevant HV winding connections. You've got an LV winding with the relevant LV winding connections. You've got your winding supporting blocks. You've got your rating plate. You've got a PT100 box, which is basically where the temperature sensors are wired to. We'll get to that a little bit later. You've got your HV tappings, where you can control your voltage. You've got pulling holes, scrolling wheels, and then, of course, lifting lugs to move and rig the transformer into position or wherever it's needed. Let's have a quick look at some of the construction of the main components of cast resin transformers. As we all know, the magnetic core is an integral part of any transformer. And these magnetic cores are made from cold rolled, grain orientated magnetic sheet metal that is isolated on both sides. These individual sheets are cut as needed and then combined and assembled into limbs cores using the step lap technique. The assembled core is held together with core clamps, top and bottom usually. These core clamps are usually designed to provide the best solution for mechanical and electrical requirements. Magnetic cores also comes in a big range of classes or types. These classes and types can be used to assist the design engineer to fulfill the requirements of the client, such as no load losses, dimensions, and noise levels. Please keep in mind that the core of the transformer forms a large part of the total cost of the cast resin transformer. Taking this into account, the higher the grade of the core steel used, the higher the cost of the cast resin transformer will be. So it's always a good idea to find a good balance between performance and cost when it comes to your magnetic core. The LV winding is always fitted coaxial to the limb of the magnetic core. They are manufactured using very specialized equipment, specially designed to wound cast resin transformer LV windings. These LV windings are usually manufactured in a round shape by using aluminium foil and 100% pre-impregnated interlayer insulation. By using this type of configuration for your LV winding, it also provides the LV winding with excellent insulation and mechanical properties. For the LV terminations or buzz bars that needs to be welded onto the actual foil of the LV winding, an automatic welding machine is used. This ensures that there's no imperfections or sharp edges on that weld, which could lead to interlayer insulation failure due to the stresses of the transformer during normal operations. Once the LV winding process has been completed, the complete winding needs to be heat treated and allows for the activation of the pre-impregnated insulation. This process bonds the entire LV winding that prevents moisture absorption and provides the needed properties to the winding to be able to operate in high moisture environments and achieve an F1 classification. Let's have a look at the HV winding. The HV windings are coaxial to the LV windings and limb of the magnetic cores. These windings are manufactured using very specialized and automated winding machines. The HV windings are also usually round in shape, and a round former is used to form the base of the HV winding. The former is usually covered with a layer of resin impregnated fiberglass mesh, providing mechanical strength to the resin during the casting process and preventing the movement of the winding during the process. The mesh actually acts as rebar for concrete for the resin. So it just adds mechanical stress and reduces cracking of the resin under normal operating conditions. The HV winding conductors are then wound over the mesh in a disc formation with double 100% saturated interlayer insulation. During the winding process, the voltage regulation tappings are also brought out to be connected at a later stage. This type of winding process ensures windings are capable to withstand the stresses subjected to the transformers during the testing and its working life. So if you look at the photo, there's a typical winding machine that is used to wind HV windings. There is the round former with a resin mesh around it, with the HV conductor being wound on top of the mesh. Then there's a typical example of a completed HV winding where you can see the relevant tappings coming out. There's a nice schematic diagram showing the typical construction of a high voltage winding. And then the last picture shows you just some tapping positions and how the tappings are orientated on a high voltage cast resin transformer winding. So after the HV winding has been completed, this HV winding needs now to be prepared for the casting process. This is done by adding another layer of resin impregnated fiberglass mesh around the HV winding. And then all the connections, the start, the finish, the tappings needs to be connected to the outer former faceplate. Once all the connections have been completed, the outer former can now be fitted around the HV winding and joined to the faceplate of the outer former. There's some typical examples of the resin on the outer layer fitted outside the windings. There's some the tappings going to the relevant tapping sections and the start and the finish of the transformer. And then there's the completed jacketed high voltage winding ready to go to the casting process. So now let's have a quick look at the actual casting of the HV winding. Once the jacket pre-casting process has been completed, the HV winding can now be encapsulated, casted with epoxy resin combined with quartz and aluminium thyrate. This process is done in equipment, typically autoclaves, specially designed to automatically mix the materials to the correct ratios under controlled vacuum and temperatures. This pre-mixed resin is then injected into the former for the high voltage winding under a specified vacuum and temperature to ensure excellent degassing of the casting process. Should we not degas the casting process properly, you will commonly find porous areas in your casting, and this would lead to high PD levels of the HV winding, which will eventually result in failure of the transformer. So it's very important that this whole entire casting process is done under a very strict, controlled and automated conditions. So once the casting process has been completed, the HV winding now needs to be subjected to a heating cycle. This allows the correct jellification and curing of the resin. So should you also not follow the prescribed heating cycle, you will also find that the resin will either cure too quickly or too slowly, also causing compromising the insulation and later the PD testing of that high voltage winding. Once the heating cycle has been completed, the outer and inner formers or jackets can now be removed, resulting in a complete casted HV winding. Using this casting process provides the HV winding with excellent dielectric and mechanical properties, allowing the winding to withstand various stresses experienced during the testing and its lifespan. Below is just a typical example of a casting plant where the above casting process will take place. And then there's basically the end product after the HV winding has been casted. So this is what you will generally get after the casting process has been completed. So now that we've had a look at the basic standards, specifications and construction of a cast resin transformer, let's look at some of the protection needed for cast resin transformer. So we all know the usual protection systems that are used for oil type transformers. They are sometimes very complicated and can give you nuisance tripping and leads to a lot of downtime and unnecessary power outages. Cast resin transformers uses a very effective and easy to operate protection system. This protection system is based on monitoring the LV winding and core temperatures. This is done by locating a removable temperature probe in the LV winding and core at a specific position. These temperature probes are then connected to a temperature monitoring device, sensing the average winding temperature of the LV winding and core. These temperature monitoring devices are usually preset to values as per the manufacturer or as per the temperature class of the transformer, and is usually equipped with outputs. These outputs can be used to activate or de-energize the RMU or protection system of the transformer. For example, typically it will have an alarm contact, which usually is wired to a siren or a flashing light or something to indicate to the end user or user of the transformer that the transformer is in an alarm state. It also usually has a trip contact. This trip contact can be used to trip the RMU for the transformer. It also has a fan contact, which can be used to energize and de-energize fans if needed. And it also has a fault contact that can also be used to trip the RMU or the supply to the transformer. This fault contact usually activates if the protection monitoring device loses power or the signal from one of the temperature probes is lost. So you get a whole different bunch of temperature monitoring systems, and they come in various models and sizes. And again, you need to look at the application and the site requirements and procure your protection of your cast resin transformer accordingly. Just for your information, typically for the standard F-class insulated transformer, the standard settings would be to alarm at 130 degrees Celsius and to trip at 140 degrees Celsius, and to bring in the fans at 110 degrees Celsius and to switch off the fans at 90 degrees Celsius. Another form, as we all know, we all battle with the quality of electrical supply in South Africa. And we all know what detrimental effects load shedding has to electrical equipment. Unneeded and excessive energizing and de-energizing and switching of any transformer, especially if the switchgear is located close to the transformer, deteriorates the lifespan of the unit. This is due to an effect called fast transient switching over voltage that subjects the transformer to a very high voltage and frequency, usually exceeding the design value of the transformer, leading to the deterioration of the insulation and can even lead to detrimental or catastrophic failure of the transformer. Due to the above, it is highly recommended that a surge suppression device is installed on the HV side of the transformer, as regular surge arresters are not sufficient to protect the transformer against the effects of fast transient switching over voltages. Again, surge suppression devices should be selected and installed to suit the installation requirements and the end user's needs. There's just a typical example of some surge suppression devices available on the market. And then this is a typical installation of how you would install such surge suppression device. So let's have a quick look at the ventilation and cooling needed for a cast resin transformer. Due to the fact that cast resin transformers use natural air and sometimes forced air as a cooling medium instead of oil, it is very important to ensure the airflow requirements are considered during the design, manufacture, and installation. Depending on the site installation conditions, the ventilation cooling of the transformer should be adapted to suit the site-specific requirements. There are generally two types of installations for cast resin transformers. As a cast resin transformer is manufactured as an IP00, it can be installed indoors as a freestanding transformer. If the installation area is well ventilated and prevents contact with live electrical parts and prevents the ingress of foreign or unwanted materials. Cast resin transformers can also be installed outdoors in specially designed enclosures suited for the application and installation. It is recommended that these enclosures are rated at a minimum of IP43. Higher IP ratings can be obtained for these enclosures. However, as soon as you go higher than IP43, you usually need to use forced air cooling to ensure the ambient temperature in the enclosure is kept below 40 degrees Celsius. As a good rule of thumb, 4 cubes of fresh air per minute for every 1 kilowatt of losses generated by the transformer is a good guideline to use when considering the needs for cooling cast resin transformers. Ventilation bars are also available that can be fitted at the bottom of the cast resin transformer. These ventilation bars are controlled by the previous mentioned temperature monitoring device. These fans only assist with the cooling in cases where the cast resin transformer is subjected to higher than designed ambient temperatures and or the deterioration of ventilation or even short periods of overloading. So if you look at the picture, it's clear that cast resin transformer use natural air cooling. So cold air comes through the bottom, it heats while it's flowing through the transformer, and hot air leaves out the top. So taking that into consideration, as mentioned, you need to ensure that the area the transformer is installed in is suitable for the cooling needed for the transformer. The next picture, you can see this is a typical cast resin transformer enclosure. You will see it has a lot of louvers for ventilation and cooling. Again, you get various sizes, colors, shapes, and most manufacturers will assist and design enclosures to your requirements and specifications. The next picture is just a typical example of the operation of the fans. So you can see the fans are mounted at the bottom, usually on the HV and on the LV side of the winding. And cold air is then forced through the transformer to try and get rid of excess heat build up during high ambient temperatures or short periods of overload. This is a typical example of what a fan bar looks like. And this is a typical installation of fan bars on cast resin transformers. When you are procuring a cast resin transformer, it is very important to supply your manufacturer with some basic information. This will allow the manufacturer to actually design the transformer specific to your requirements. You can see on screen, there's a typical example. kVA rating, primary voltage, secondary voltage, vector group, installation class, winding conductor material, do you want aluminium or copper? K factor, is there some harmonics that needs to be factored in? Frequency, number of phases, tapping range, so you can order your transformer with various tapping ranges. Highest ambient temperature, this is quite a very important one, as cast resin transformers use natural air. So if you've got a very high ambient temperature, the cast resin transformer needs to be designed to accommodate that high ambient temperature. Altitude of installation, place/area of installation, and very important, a minor description of the installation. Is it a solar installation? Is it a nuclear installation? Is it a wind farm installation? Is it a data center installation? This will guide your manufacturer to have a better idea of what is required for your application. Then, of course, the additional information that needs to be provided. Do you need an enclosure? What IP rating does the enclosure need to be? Do you require forced cooling or fans? Do you need additional auxiliary panels to wire contacts to? Scroll wheels, PT100, temperature anti-vibration pads, shields between windings. This is typically for solar installations where you've got high harmonics. Surge suppression device, CTs, and of course, do you want your manufacturer to deliver to site? Something to always also keep in mind when you order your cast resin transformer is also tell your manufacturer you would like him to deliver or install or commission the transformer with you. This is always advised, as there's not a lot of experienced technicians around to actually commission and install cast resin transformers as needed. Also ask your manufacturer for maybe for a maintenance plan. Cast resin transformers don't use a lot of maintenance. We'll get to that now. And then, of course, what type of testing would you like to be done on your cast resin transformer? Obviously, routine testing has to be done by the manufacturer. And then obviously all the other types of tests that is required. Please just keep in mind, should you require some of these type tests, they are very costly to conduct. And sometimes if you need a full type test to be done, the actual cost of the type test becomes more than the actual transformer. And again, please remember to ask your manufacturer, supplier, or installation specialist for guidance and advice before placing an order. The last thing that you want to do is when you receive your transformer, realize that it's not actually what you wanted or it's not what you require. So let's quickly have a look at the advantages of cast resin transformers. We are all familiar with oil-filled transformers as they have been used for a very long time in South Africa. And we all know the usual suspects and issues that we see with oil-filled transformers. Leaking transformers, leaking bushings, taking oil samples, changing oil, faulty protection systems, and of course the environmental impact today. Everybody wants to reduce their footprint and conform to environmental and health and safety requirements. So let's quickly discuss some of the advantages of cast resin transformers over oil-filled transformers. As I mentioned, cast resin transformers do not have any oil in them. No oil means no leaks. No oil also means lower risk to fire, and also no environmental impact should the oil leak. Cast resin transformers are designed and manufactured to be flame retardant. So as I've discussed, most cast resin transformers carry the F1 rating, which means they do not burn. So even I have experienced personally where a complete installation has burned down. However, the actual cast resin transformer is still intact. You can still recognize the cast resin transformer due to its fire resistant properties. Cast resin transformers can easily be designed and installed according to customer specification and needs. Cast resin transformers are small and can be designed in various shapes and sizes to fit into small spaces if needed. A typical example will be on cargo ships where you do not have a lot of space and you've got very high humidity. Cast resin transformers are ideal for such type of installations. It's very easy to perform maintenance and visual checks on cast resin transformers. The average maintenance time for a cast resin transformer is between half an hour and an hour. This involves cleaning the unit, torquing all the relevant electrical connections, and doing some basic testing on the unit. There is no need for taking oil samples and submitting and waiting for results. It is very easily maintained, and depending on the environmental and installation site conditions, it is recommended to maintain your cast resin transformer every 6 months to a year. Cast resin transformers can be recycled if needed after its lifespan has been reached. 90% of cast resin transformer material can be recycled. Cast resin transformers provide lower installation cost. If you think about oil transformers, you have to build blunt walls, you have to build sumps. Cast resin transformers can basically be put into a room or an enclosure, as previously mentioned, and operate under those conditions. Cast resin transformers also have low noise level. It has high efficiency, and ensuring a cast resin transformer or the installation reduces the insurance cost due to the lower risk of fire and spillage. Cast resin transformers also have a smaller footprint. If you think of an oil transformer, Again, you need a bunt wall around the oil transformer. You need cable boxes. You need conservators. You need radiators. All of these items on oil transformers take space. Cast resin transformers don't need any of the before mentioned, and this has a smaller installation footprint. Again, it's very easy to do visual inspections of the windings and assembling during manufacturing, testing, and commissioning. Usually when you order an oil transformer and you go and do the testing, it's already closed and they just test the transformers for you, and you can't actually see what's happening inside the unit. With cast resin transformers, you are able to actually see the windings and see the connections, which is a major advantage. In conclusion, cast resin transformers are well suited for the South African market and have successfully been used in South Africa for the mining, industrial, commercial, data centers, generation, and renewable sectors in the past 10 years. With the growing expectations of reducing our carbon footprint, adhering to health, safety, and environmental requirements, the rising cost of downtime and maintaining equipment, the cast resin transformer is the way forward. Oil-filled transformers will never completely be replaced in South Africa. However, from the above information provided, we hope you will consider cast resin transformers in the future, as they have a smaller environmental footprint with various other added advantages. The combined advantages will save project and maintenance costs in the long run and lead to a greener world for future generations to come. Thank you for allowing me to present this webinar on cast resin transformers. For any additional information, please feel free to contact me. Thank you.
Okay, thank you. Now it's thanks, Mr. Zander, for a brilliant presentation. Actually, yeah, it was an eye opener. And also, let me take opportunity also to thank Mr. Pedi Padayachi, Managing Director and CEO of Revive, also for giving you opportunity to come and share this interesting topic with us. Mr. Pedi is also on the attendees today. Means now I can't see the questions. I'm not sure if it shaded I cannot click.
No, Tabang. We have just one comment that just came in from Mr. Mbiko Sabia. We encourage our attendees to ask questions. Please, we will answer it now by Mr. Van Rooyen. Mr. Sabia is saying, thanks for a wonderful presentation. One, what are the transportation requirements, i.e. vibration limits of a small CRT, for example, 100 kVA, compared to oil-filled TR transformers? Sometimes transformers sometimes fail during transportation. Second question is asking, would you say cooling of a CRT is a challenge when compared to oil-filled transformers?
Okay, so to answer his first question, it is always recommended to transport cast resin transformers on air suspension trucks. And also to ensure that the cast resin transformer is placed on a rubber dunnage when loaded onto the truck. Yes, in comparison to oil, you need to be a little bit more careful when it comes to cast resin transformer, as oil tends to dampen the vibration effect of transport. However, again, it is very important to make sure that when your transformer reaches its destination, that it is inspected and checked before commissioning and energization is done. to identify any issues. Usually it's just a loose bolt or a loose clamp somewhere. However, there's ways and means to prevent it by putting lock nuts, nylon lock nuts and spring washers. Usually prevents movement of the windings and stuff. The second question, as I explained in the webinar, oil transformers can basically be installed in any condition, inside a room, outside, wherever you needed. The cast resin transformers, you need to take into consideration the ventilation requirements of that transformer. If you do not address or you do not have sufficient natural airflow for the cast resin transformer, you are basically going to build the oven. So the transformer is going to heat up that room. When the room heats up, the ambient temperature of that room increases accordingly. And then that heated, already preheated air is now trying to cool the transformer, which is just getting heated again and heated again and heated again. So in essence, if you do not have a well ventilated room or area, it is suggested that you install extraction fans just to extract the temperature of that or extract excessive heat, to ensure the temperature of that room stays within the design parameters of the transformer. I hope that answers the question.
Thank you very much, Zander. Mr. Paulo D'Amato say thank you for the presentation. And we have another question here from a Mr. Randall Kruger, who's asking what causes HV winding resin to crack?
Okay, so there are various reasons why the high voltage resin will crack. So in some instances, you will find the manufacturer did not include that mesh, the fiberglass mesh, which leaves the resin very vulnerable to cracking. The other reason why the transformer resin will crack is if the resin and the winding conductor is not paired together. So as the transformer heats, the winding conductor expands and the resin is formulated to expand at the same rate as the conductor. Should this not be the case, the conductor will actually expand and the resin will not expand accordingly and cause cracking. The other reason why cast resin transformers HV windings crack is also overload. So if that transformer is overloaded for a very long period of time and the protection system is not functioning as needed, the HV winding material actually deteriorates and forms small cracks in the HV winding. Again, all of this can be prevented if you look at your installation and design requirements at procurement stage, ensuring that your manufacturer of your transformer knows exactly what the specifications and the requirements are for that installation.
Thank you. We have a next question from Mr. Kaniwi Matufi. He's asking, what are the long-term storage requirements for CRT?
Okay, so due to the fact that cast resin transformers are basically 100% saturated, no moisture can penetrate the winding, there's nothing that can absorb moisture. So my recommendation would be is to wrap the transformer or shrink wrap the transformer with silica gel just to make sure there's no moisture and exposed metal parts don't rust. And then after the storage period is completed, to actually just do basic testing on that transformer. For example, mega testing, checking the installation of the insulation level of the transformer, and doing maybe a ratio on the transformer will be a good idea, just to give you a good indication if something went wrong during the storage process. Again, cast resin transformers, I've seen where they put them outside in the veld, and basically the grass grows through them, and they're full of dust and birds' nest, and they literally take it and wash it off with water and let it dry properly in an oven, and then the transformer functions again.
Gosh. Thank you, Zander. Another question we've got here from Mr. Paulo Dumatos again. What are the physical size comparison between CRT and oil-filled transformers?
So if you look at the only the transformer, cast resin transformers are much smaller than oil-filled transformers. The problem comes in if you need to put the cast resin transformer in a enclosure. So then if you put the transformer in an enclosure, the size becomes more or less the same. Once you go to let's say up to 2 MVA, cast resin transformers footprint actually becomes smaller than an oil transformer inside the enclosure. So yes, it depends on the size and the application of the transformer.
Thank you. A second last question we have here from Randall Kruger again. He's asking, is it a serious issue when the HV winding resin cracks?
This is definitely a high risk situation, because what happens is if the HV winding cracks, it allows moisture ingress. And once you have moisture ingress that gets close enough to your actual winding conductor, this will lead to interlayer or interturn failure of that winding. I will recommend that he contacts a service provider or a transformer dry type transformer specialist to actually have a look at the type of the crack, and if it's still in the beginning stages, it might be able he might be able to actually repair those cracks before it gets too worse.
Excellent, thank you. And our last question this afternoon is from Mr. Paulo de Matos again. Is the 1 MVA CRT the same as a 1 MVA oil-filled transformer?
So if I quickly have to think, yes, they're more or less the same footprint. If the 1 MVA oil transformer is fitted with cable boxes and a buchel and a conservator and radiators and all that, the footprint, the actual footprint of the cast resin transformer inside an enclosure is very similar to that of an oil transformer. Obviously, that will differ if you use a completely sealed transformer without all the accessories. Then that sealed oil transformer will have a little bit smaller, but not there won't be much significant change, but there will be change. So to answer his question, a 1 MVA cast resin transformer inside an enclosure will be more or less the same size as a 1 MVA oil transformer with all the relevant fittings.
Thank you very much, Zander. That's all for the questions. Over to you, Thabang.
Okay, thanks, Mix. In closing, I would like to thank you, Mix, also for organizing this webinar. I know it's not easy from your side. You are always busy. And secondly, I would like to thank our presenter, Mr. Zander, for coming and share this interesting topic with us. And also, I would like to acknowledge Mr. Pedi, also CEO of Revive and Managing Director, to give Zander opportunity to come and share this interesting topic with us. Lastly, I would also like to thank attendees. I just want to remind attendees something. In our chat box, like we said, the activities that are happening in SAIEE, please go and check them. And then we have a YouTube TV. Subscribe to it. You will see the interesting topics. I think that's all from my side. Thanks, everyone. Then we can officially close. Thanks, Minx.
Pleasure. Thank you, Tabang. Thank you for hosting this. And to Mr. Van Rooyen, thank you for availing your time. And thank you to our attendees, the most important. Thank you for joining us this afternoon. Have a good afternoon. Goodbye.
Bye.